Okay, so let's define the principal value function of 1 over x. Okay, let's denote it as pb over x, and this is defined by the expression pb 1 over x psi limit when e goes to 0 of the integral e epsilon x 1 over epsilon phi of x dx. Okay, this is for any phi in the Schwarz space, one-dimensional in R. Okay. Okay, so notice that you can write the principal value as the following way: integral of x1 phi of x minus phi of 0 over x dx. Okay, with the epsilon plus sine naught over x, again x1 plus integral of phi of x over x absolute value of x more than 1 dx, and here also had to be a dx. Okay, so you can see that this integral, knowing that phi of x and phi of 0 over x absolute value, this is bounded by the norm of phi prime, norm infinity. So the limit of this integral exists. So this integral will exist, and then we will have to see what happens with the other two. So this integral, this one, will be 0 because of symmetry, by symmetry, and this integral will be bounded because phi of x is in the Schwarz space. It's decaying quickly in infinity. Okay, so the principal value function 1x phi will be bounded by symmetry 2 times in norm infinity of psi prime plus 2 times x multiplied by psi. Okay, this is how we bounded the integral that had phi x over x for absolute value of x more than 1, greater than 1. Okay, therefore we can say that the principal value function is a distribution in S prime of R. Okay. Okay, so what happens with the principal value of 1 of x transform? Okay, so as we saw before, the principal value of 1 of x, the transform had to be phi transform, and this will be the same as saying that the limit epsilon goes to 0 of the integral e less than x less than 1 over epsilon phi transform x over x dx. Okay, and this will be equal to the limit epsilon goes to 0 of the integral epsilon absolute value of x 1 over epsilon 1 over x integral minus infinity psi phi of y e minus 2 pi I x y dy dx. Okay, so we just applied the transform formula. Okay, and we will use Fubini's theorem and Levesque dominated convergence theorem, so that we can change the integrals and take the limit inside the integrals. Okay, so this will be equal to the limit, first of all, of the integral minus infinity phi y, and now we have the other, this is Fubini's theorem, epsilon absolute value of x 1 over epsilon e minus 2 pi I x y over x dx dy. Okay, and now we're going to use dominated convergence theorem, obtaining the integral phi y. Now we have the limit inside the integral. Now the other integral absolute value of x 1 over epsilon e minus 2 pi I x y over x dx dy. Okay, perfect. So I'm not going to do it, but changing this term e to minus pi I x y over x, one can when you transform this into a sine of 2 pi xy, one can prove that this integral is equal to minus I pi sine y. Okay, then the integral will be equal to minus pi I pi integral minus infinity sine y phi y dy. Okay, and so the transform of the principal value, it will be minus I pi sine psi. Okay, so now we can define, similarly as we did before, let psi j included in x prime or n now, then psi j goes to 0 when j goes to infinity in x prime r n if for psi that is in s r in Schwarz, it follows that psi j of 5 goes to 0 as j goes to infinity. Okay, this is a similar definition as we did before with the Schwarz space and the size. So as we did before, now taking into account x prime of Rn, the distribution, temporal distributions, one can prove that the transform going from x prime of Rn, okay, x prime of Rn is an isomorphism, okay, this is an extension of what we told before about the Fourier transform, but in the short space. Now we're talking about the Fourier transform going from temporal distribution to temporal distribution is an isomorphism.